For this one, I'm going to go through three different graphs here. The first one that we're being asked to graph is a cubic function. And with the cubic function, this looks like it's already in what we like to call transformation form, where we have like this h and k value, which tells us kind of where we should probably start plugging in numbers. And so in this one here, when we plug in negative or 4 and -5, that will kind of give us what I like to call the turning point of a cubic function, because a cubic function usually a positive one looks like this, a negative one looks like this, when it's in transformation form at least. And so this h and k value, shifting 4 units to the right and 5 units down, tells me where that turning point is, or where it starts to change which way it is curving. And so from here, I'm just going to kind of create an x and a y table. And I'm going to try and get 5 points, hopefully, that land on the graph, but it may or may not work out. So the first x value is 4, and the first y value is -5. And now I'm just going to actually like plug in some values into the equation, right? So 2 times 5 minus 4 cubed minus 5. And that becomes 2 times 1 cubed, which just becomes 1. And that ends up giving me -3. So in this one here, I have my second point. And then let's try to plug in 6. So same idea here, 2 times 6 minus 4 cubed minus 5. 2 times 2 cubed minus 5. 2 cubed is 8. And that becomes 16 minus 5, which is 11. So it just barely lands on our graph. I'm going to do 1 to the left now. Oop, not -3, but just 3. And when I plug in 3, I get 2. I'm going to run out of space there. 2, 3 minus 4 cubed minus 5. So in this one, 2, -1 cubed. -1 cubed is just -1. And we get -7 here. So -7 lands right here. And it seems to me like the next one's going to land off the graph. So really, it kind of has this curve, this on the left side here that's curving and kind of flattening out. And then the other side, that turning point, now it's curving up. And it's really stretched out. But that's our cubic function there. Second one that I'm going to ask to graph is a polynomial. And so to graph this one here, I'm first going to find my x-intercepts. And so I know that if I plugged in the x value of 3, that would give me 0. If I plug in my x value of 1, that would give me 0. And if I plug in the x value of -2, it would give me 0. So I know it's going to cross at all those points, or at least touch at all those points. The other thing that I know about this is that looks like it's going to be a power of 4 graph, because if I were to expand this, it'd be x minus 3 times x minus 3 times x minus 1 times x plus 2. And if I multiplied that all together, I'd get this x to the power of 4. And so I'm going to get this shape kind of like a W here, since it's a positive a value. And I know that it bounces off at this point right here because of this squared. So again, at this graph here, I got to figure out what the y-intercept is going to be. And so when I'm doing that, I'm really just saying like, hey, what is y when I plug 0 in for x? And so y equals 1/9. 0 minus 3 squared times -1. 0 minus 1 times 0 plus 2. So I get y equals 1/9 times -3 squared, which is just 9, times -1 times 2. Multiply these together to just get 1. And then I multiply all these together and I get my y value of -2. So now when I graph this, again, it's this W shape. It goes through the first point, through the second one, and then it bounces off of that one here. And so my x and y intercepts are all correct, and I have the end behavior correct. And so that's a pretty decent sketch of that one. Last one, same idea here. It's going to be a polynomial. So I'm first going to find my x-intercepts at +5, +1, and a -2. It's going to bounce off at, let's do this in blue here, at the +5. It's also going to bounce off at the +1, and it will go through at -2. Because it's a fifth, it looks like x squared, and x. It's going to be x to the power of 5. And since it's negative, I should have something that looks like, ooh, like this maybe? 1, 2, 3, 4, 5. Yeah, something like this-ish. And I'm going to find the y-intercept by plugging in 0. So negative 1/10, 0 minus 5 squared, 0 minus 1 squared, and 0 plus 2. Negative 1/10, this becomes negative 5 squared, which is 25. Negative 1 squared, which is just 1, and 2. Then this here becomes negative 1/10 times 50, which gives me just negative 5 as my y-intercept. And so I plot that point. And now I'm going to go ahead and try and draw my graph here. I know that it starts at the top, goes through the first point, bounces off the second point. It's also going to bounce off that point. I have my end behavior right. I have all my intercepts correct. And so that's a pretty decent sketch.